This video, we're going to be looking at arc length and sector area of a circle. In this video, I really want to emphasize a really big idea here. When you find arc length and sector area, I want you to think in terms of proportions. Proportions are really going to help you out when finding these two measurements. When it comes to finding the arc length of a circle, the arc length is basically the distance of part of the circumference. So if we were to look at this angle here, this x, which we actually call the central angle. If we look at that central angle, we'll notice that it forms where the radii meet with the circle, the outer edge of the circle, it forms this length here. And this length here is what we call the arc length. Okay, and so that's what we're going to be looking for. You'll notice that it's part of the circumference. So it's going to be part of the circumference. Okay, so that's why if you think about what circumference is, the circumference is the whole length around a circle. And what we're trying to find is just a piece of that whole length around a circle. So let's take a look at example 1 and find the arc length. Given circle O, find the measure of arc AB. Well, it actually tells us that right here. The measure of arc AB is right there, is given by the angle of pi over 3, and because we see that pi, it's in radian format. Okay, so for question A, we see that the measure of arc AB is given by pi over 3. And remember that this basically is your central angle. The central angle is where the center of the circle forms that angle measure given the radiuses, the radii, sorry. Is that the same as the length of the arc? No, it's not. It's not the same as the length of the arc. You'll notice that this is an angle measure. It's an angle measure. But what we're trying to find is the length of the arc is really going to be a distance that you can kind of measure like with a ruler. Okay, so how long is that piece of the arc? Now, just because you have a central angle of pi over 3, you can have different arc lengths associated with this angle. Because if you think about it, I can have concentric circles. I can have a circle with a radius of 8, or even like a radius of 16, right? I can have a bigger circle outside that. And even though they have the same central angle, it would end up having a different arc length. As you can see here, this is going to be a lot longer than my previous arc length. Okay, so how would you exactly find that length? And that's the idea I have brought up to you before. This is why we want to think of proportions, because everything is proportional on the circle. So in terms of proportions, keep in mind that what we're thinking about here is the part compared to the whole. And what are we trying to compare here? Well, we definitely know because we want to find a length, the length should be a part of our proportion in some way. We want to find that length. And what we want to compare that to is kind of what we know. What are the parts and wholes of things that we know? Well, we want to find a part of the circumference compared to the whole of a circumference. But what else do we know? We also know part of the angle that makes up the whole of an angle of a circle as well. So we're going to compare the length versus the angle. Okay, so when it comes to this particular circle, a piece of the circle that we know, the part that is definitely kind of emphasized here, is that we have an angle measure of pi over 3. This represents the part of the angle that we know. Now compare that with the whole of the angle we know. What do we know about an entire circle? An entire circle has a complete angle measurement of, in terms of radians, 2 pi. So we're comparing pi over 3 versus an entire 2 pi of a full circle. So that's creating a ratio between the angles. And then we're also going to create a ratio for the lengths of what we want to find too. What we want is the arc length, this part right here, which in this case I'll just call L since we can represent L with length. So I'm going to say that the part is L, that's the length of that piece, the arc length, and compare it with the whole of a circle. What's the whole length of a circle? Well, that's the distance around a circle. Think of that as circumference, or we know circumference is the same as 2 pi times r. Okay, so here we have basically set up a proportion in solving for the arc length being the L value. Okay, we can just plug in some numbers. We definitely see that right here the radius is 8, so I'm going to go ahead and plug in L over 2 pi times 8 is equal to, again, pi over 3 over 2 pi. And then from here, we can simplify, right? So we can bring the 8 times 2 pi over to the other side, right? And then that way the L is now isolated. And the reason why I didn't multiply 8 and 2 to give me 16 is because I can just see that the 2's cancel out anyway. If you take a look at what's going on here as well, we can see that the pi's also cancel out, and you're also left with this pi left over here. So what do we have left over? Well, we see that L is equal to an 8 on the top, with a pi on the numerator as well, and everything is being divided by 3. So we have 8 pi over 3. And we'll just give a unit of measurement. We'll just say units. So our arc length is 8 pi over 3 units. Okay. So number 2 is basically the same idea. I'll let you do that one, and you can see that this one's in degree format. Okay, you can pause the video and work on that. And then when you come back, unpause. Let's take a look at the general formulas that you basically created in terms of finding the arc length. So I'm going to go ahead and write the formulas for how we can find arc length in this space here. Okay, so to find arc length in general, what we are given is an angle measurement theta and a radius r. Now, if you notice what you did in problem 1 and problem 2, one of them was given with an angle measure in radian format, and then in example 2, the angle measure is given in degree format. So it turns out we can create 2 formulas for arc length depending on what kind of angle we're given. If we're given theta in terms of degrees, then again, think about it as proportion. You're comparing length versus angle. And when you do that, you're basically saying the arc length, the part over an entire circle's distance, length around a circle, which is circumference, 2 pi r, is equal to the part of the angle, which we represent as theta, over an entire circle's angle measurement. Remember that we are going to be in degree format, so that's going to be 360 degrees. This hopefully was the proportion that you used in setting up number 2. If you didn't do that for number 2, well, go ahead and pause the video again and retry it and see what you get for your answer. Okay? But in essence, when we want to solve for arc length, if we basically want to isolate L, you can see that L is equal to 2 pi r, bringing it over to the other side, times theta over 360 degrees. Or, simplifying it through, we see that we get pi over 180 degrees times r theta. And so that's going to be our arc length, given that theta is in degrees. Okay. Now, we also have another form of measurement. If the angle measure is given in radians, that's the example 1 that we did up above, then again, we're creating a proportion where we compare length versus angle. And again, that proportion is still the same. We think about the part of the circle that we want to find. This right here is what we call the L. Compare it with an entire circle's length, which is circumference, 2 pi r, and then we compare that with the angles. The part of the circle we know is theta, and then the entire circle's angle measurement, we know, well, in terms of radians, remember, it's not going to be 360 degrees. Instead, in terms of radian measures, that's going to be a value of 2 pi. So from there, again, solving for L, we can see that bring the 2 pi r over to the other side. L is equal to 2 pi r times theta over 2 pi. And you can see the 2 pi's cancel out. So L is equal to, what's left over is r theta. And that's going to be your arc length formula in terms of radian measures. Okay, so you have 2 choices here. One, if you are really a stickler for formulas, you just want to memorize formulas, here it is. If you want to find arc length in degrees or arc length in radians, memorize those formulas. Me personally, I don't really like to memorize formulas. Instead, what I like to do is I like to think about it in terms of proportions. And I can always set up my proportion the same way, and that way I can always get to my missing variable. So you can go either of those ways, either think proportions or just memorize formulas. Your choice, okay?